Good evening, my YouTube viewers. I'm doing a practice question on software and hypothesis test, and there's a possibility that you may have watched my first video, which I have deleted, but I wasn't really happy with the first video, so I deleted it. But you may have watched it before I deleted it. So I went and fiddled around with the code a little bit and got it to work a little bit better than what it had been doing. So I decided to go ahead and do this video again. So this is a practice question with regard to software, and it's a software feature will reduce the average response time. Current average response time is 4.5 seconds. Take a sample of 25 responses and see if the response time has reduced. Perform a one-tailed left t-test. So the null hypothesis is the sample mean is greater than or equal to 4.5 seconds. And an alternate hypothesis is a sample mean is less than 4.5 seconds. So we're going to write a program in Python to answer this question. But before we write the program in Python to answer the question, what we're going to do is we're going to import 3 libraries that Python needs to be able to execute the program. So the first library that we import is NumPy as NP. So NumPy is a numeric library that performs numerical calculations. It creates NumPy arrays, and it also creates distributions. And then we're going to import scipy.stats as stats. Scipy is Python's scientific library, and stats is a statistical module within scipy. And then we're going to import matplotlib.pyplot as plt, which is a visualization library. So we're going to define our parameters. Population mean is 4.5. Sample size is 25. Sample mean is 5. And standard deviation is 0.3. And alpha is 0.5, which is your significant level. Now we're going to calculate the t-score, which is the sample mean minus the population mean, divided by the standard deviation, divided by the square root of the sample size. And I believe that's 8.33. And we're going to calculate the p-value. So the p-value is stats.t.cdf. So t means it's a t-distribution, and cdf is cumulative distribution function, brackets t-score, comma, df is sample size minus 1. So your degree of freedom is 24. And now I output the results. So we're going to print the t-score and we're going to print the p-value. So we're going to analyze the p-value. If the p-value is less than alpha of 0.05, you're going to reject the null hypothesis. The sample mean is slightly lower than the population mean. If the p-value is greater than alpha of 0.05, you're going to fail to reject the null hypothesis. The sample mean is not significantly lower than the population mean. So now we're going to plot the t-distribution. So x equals np.linespace brackets -4, 4, 1000. And y equals stats.t.pdf. So t is your t-distribution, and p is your probability distribution function, brackets x, df equals sample size minus 1. So it's going to be 24, I believe. We're going to plot the t-distribution, plt.plot, brackets x, y. Label is t-distribution, color is blue. So we're going to shade the critical region for a one-tailed left test. And so this is where I had problems, and I went through and I studied the code and I rewrote the code. So I hope that I've rewritten it correctly. So we're going to make it a one-tailed left test. The critical value is stats.t.ppf. So T is your T distribution, and ppf is your percentage point function, and brackets alpha, comma, df equals sample size minus 1, so that's 24, and df is your degree of freedom. Mask equals x is less than or equal to critical value, and you're going to use this for a one-tailed left test. plt.fill between brackets x, comma 0, comma y, comma where equals mask, comma color equals red, comma alpha equals 0.5, comma label equals critical region. So now we're going to mark the t-score on the plot. plt.ax line brackets t-score equals color equals green, line style equals dashed, line width equals 2, label equals t-score. So we're going to add titles and labels to the graph. The title is one-tailed, we're going to say left test. The X label is your t-score, your Y label is your probability density, and then you get a legend. But what I'm going to do is I'm going to go through and I'm going to run the program again. We're going to run it again. So you can see that your t-score is 8.33. It's a very high t-score, and your p-value is 1. So with the p-value of 1, it's greater than the confidence significance level of 0.05. So that means you're going to fail to reject the null hypothesis. The sample mean is not significantly lower than the population mean. And so this is it's a one-tailed left t-test. So this is the chart that I made, which I had to rewrite the code. But blue is your t-distribution, red is your critical region, and green is your t-score, which you can see has just gone right off the chart. But whenever I tried to do a one-tailed right test, the critical region was on the right side, and that wasn't correct. So there was actually a problem with this code, and I had to go through and check the code out, try to find out what was wrong with the code, rewrite the code where I showed you where I had rewritten it, and rerun the code. So this is it, and I had actually checked the t-score of 8.3333 on my calculator, so I double checked it on my calculator, so there's nothing wrong with the t-score. So that concludes this video. This is the second time I've made this video, so there's a possibility that you may have seen the first one before I deleted it. So the next one is going to be another hypothesis test, and I hope that you decide to watch it.